Hi everyone, welcome to Mr. Techpathy Tutorials. This is part 12 of Linux device drivers. In earlier session, Linux device driver part 11, we learnt about basics of device drivers. We briefed about character, block and network device drivers. If you have not seen part 11, please watch it before proceeding further. In this session, we will discuss following topics. First topic is books to refer for Linux device driver programming. Second topic is our main goal to achieve in upcoming sessions. Third topic is steps to follow while Linux device driver programming. Under this particular topic, we learn about gathering information about Linux device driver, gathering information of Skull device driver, identifying and defining major and minor numbers, representation of device numbers. So let's start with our first topic, books to refer for Linux device driver programming. First thing to consider before Linux device driver programming is to collect necessary material needed to refer while learning process. Apart from various articles on Linux device drivers available in net, I would like to mention about a very useful book for Linux device driver programming. As mentioned in my earlier tutorials, Linux device driver book from RLA is the rich source to learn Linux device driver programming. All our topics will be referred mostly from this book. I strongly recommend you to buy a hard copy of this book. It will be handy while programming and debugging. Also, a soft copy will help you to quickly give a search for required topic. You can download a soft copy of this book from this URL. For your reference, I'll copy this URL in below show notes of this video. Coming to our next topic of this session, our main goal to achieve in upcoming sessions. Let's keep our goal to write a simple character device driver called Skull, where Skull full form is simple character utility for loading localities. First letter in each word of this particular sentence is used to form a name called Skull. From here on, we'll keep our goal to program Skull device driver step by learning basics of Linux device drivers. So please get familiar with this name. Skull is a character device driver. Few may ask why character device driver is chosen, why not block or network device drivers. We have chosen character device driver because it's easy to understand than block device drivers and network device drivers. Also, it's more suitable for simple hardware devices. From here on, we'll code small snippets of Skull device driver and finally integrate them to form a real device driver. This approach may seem slow, but it's highly effective if you follow correctly with patience. So please be patient. I assure you that your patience will surely pay off at the end. Coming to our third topic, steps to follow while Linux device driver programming. As a part of writing Linux device driver, we need to gather information necessary to design and program device driver. Remember, if you bypass this basic information and try to start device driver coding, there is a hard chance for you to succeed or you may totally get confused. So let's cover basics first and jump into Linux device driver programming. Okay, let's start with real technical stuff. Let's follow step-by-step process to accomplish our goal. Step 1 is gathering information about the device driver. If you are going to write a device driver, we need to gather information like capabilities and properties of the driver. First, we'll discuss about capabilities. Define the capabilities of your driver. Know what exactly your driver is capable of. This information is exposed to your application by your driver. This allows the application to use your driver as per it needs by keeping limitations of drivers in mind. Coming to the properties of the driver, decide if it's going to be one device or many devices. Check if your device driver is hardware independent. Check if your driver is portable on various platforms. Capabilities and properties are just two important informations to gather about device drivers. Similar to these information, we need to gather list of mechanisms, functionalities, requirements and limitations of the device driver before programming it. Just to recap, in process of learning device driver programming, we have completed step 1. Where we learned that we need to gather information like capabilities, properties, etc. before starting device driver programming. Now with this information in hand, let's see how we can gather capabilities and properties for our Skull sample device driver. I would like to repeat again that we are going to write a sample character device driver called Skull. In this process, we'll learn necessary information required for character device driver programming and apply them to Skull device driver. Since we have learnt about gathering information like capabilities and properties in our earlier slides, let's try to gather capabilities and properties of Skull device driver. To make it short, I have named the title of this slide as Apply Step 1 for Skull device driver. Step 1 is nothing but gathering necessary information of device driver. First, let's gather capabilities of Skull device driver. We will implement Skull character device driver to access a particular memory of a device. This memory area is memory allocated by kernel of a device. It can be any device. We will refer memory area as a device here. Remember, from here on we will use memory area as a device and a device as memory area interchangeably. Here capability of Skull device driver is accessing a particular memory area of a device, and it specifies which memory area and how much memory area can an application access. Let's gather properties of our Skull device driver. Few properties of Skull device driver are: it's hardware independent, we can compile and run easily, we can even port across different computer architectures. It demonstrates the interface between the kernel and character device drivers and allows user to run some tests. These can be used as a reference to know more about your device driver. To summarize this, we have gathered information like capabilities and properties of Skull device driver till now. As a part of step 2, let's learn about major and minor numbers. These are also called device numbers. Let's take this example. As discussed in earlier tutorials, character device drivers are accessed through names in file system. These names are called special files or simply nodes of file system tree. These are located under /dev directory. If you issue ls-l command in /dev directory, you will see two numbers in the device file entries just before the date of last modification. Let's not open Linux terminal now to demo this. I'll present it here in upcoming slides. For example, let's list console file under /dev. I've used ls-l command here. We see character C in the first column of this row, stating that the console is a character device driver. Just before the date, we see the major number and minor number. The major number is 5 and the minor number is 1. This is a simple way to identify the major and minor number of your existing character device. Though we are discussing about character device drivers and block device drivers are not in scope right now, let's take an exception and see how to identify major and minor number for block device drivers. This will give us more exposure about major and minor numbers. Let's try to find major and minor numbers for a block device driver like disk. In my case, disks are listed under /dev as SDA entries. I list all my disk entries using ls command. In a console, I have typed ls-l/dv SDA star. This will list all my disk entries under /dev directory. We see character B in the first column of these rows, stating that the disks are block devices. Just before the date, we see major number of these devices is 8 and minor number from 0 to 2. Now we know how to identify major and minor numbers of character and block devices. Let's learn their exact definitions. We can define major number as an identifier which identifies the driver associated with the device. So each device will have a major number. These major numbers can be defined by us only if we know exactly which major number is available. Or you can leave this job to kernel. Either way, kernel knows to which major number our device is associated with. Please note that we are talking about defining major number here, not about identifying it. First it's defined by us or by the kernel, and later we can identify it assigned to particular special file under /dev directory. Minor numbers can be defined as an identifier which is used by the kernel to determine exactly which device is being referred to. Allocating minor number is same as major number, but only different is the kernel knows nothing about minor numbers beyond the fact that they refer to devices implemented by your drivers. Note that there can be number of devices which can be controlled by a single driver. Multiple disks with single block device driver is a good example. In our earlier slides, all disks had major number 8 and 3 minor numbers 0, 1, 2. Just to reiterate, major number of disk is 8 here, which kernel very well knows about it, whereas minor numbers 0, 1, 2 are just identifiers which kernel is not required to be aware of it. Well, we have covered how to identify major and minor numbers of character device drivers. Let's move on to our next subtopic, representation of device numbers. We very well know that the device numbers are nothing but major and minor numbers of a device. In order to represent major numbers and minor numbers in specific format, Linux kernel developers have embedded major and minor numbers in a structure dev_t type, which is defined in linux/types.h. Imagine this table as 32-bit register. First 12 bits is represented as a major number and the rest 20 bits starting from 12 to 31 represent minor number. In coming slides, we'll see how easy to represent these 32-bit device numbers with kernel-defined macros. Major and minor number macros. Knowing the fact that the device numbers are represented in a 32-bit register, we should not make any assumptions about the internal organization of a device driver. Instead, it's always recommended to use below macros. To get a minor number, use a macro minor with an argument of type dev_t. To get major number, use macro major with an argument dev of type dev_t. Calling these two functions will give you major and minor number as a part of dev structure. There is an alternative way if you already have a major and minor numbers. You can call below macro to turn them into a dev_t. Use mkdev macro with two arguments, one as a major and the other as a minor.
Both major and minor should be of type int. For your future reference, note that the Linux kernel version 2.6 can accommodate a vast number of devices, while earlier kernel versions were limited to only 255 major and 255 minor numbers. I'm not sure if format of dev_t structure may change in future as it did from 2.4 to 2.6 kernel version. So keep this in mind and write your drivers carefully. Later versions of Linux 2.4 have implementations of dev_t structure. Few kernel supports udev manager, which creates or removes device driver nodes in the /dev directory dynamically. It runs in user space and user can change device names using udev rules. We'll discuss more on this in future sessions. In order to understand upcoming tutorials, I strongly recommend you to watch my earlier Linux device driver tutorials from part 1 to part 11. If any topics discussed above is not clear, please drop your queries in comment section and I'll get back to you accordingly. If you like this video, give a thumbs up and don't forget to subscribe. Thank you.